Hello, my name is Daniel Findleton, student ID 100716573, here at Ontariotech for Industrial Design for Game Hardware, in Year 4. So today we will be looking at the design of a haptic glove. So here are the basic electronic components. Serving as a main brain, we have this Arduino Uno, which is connected to 5 potentiometers, one representing each finger. This will be used to track the individual positions of the fingers. So we have their power input attached to the 3.3 volt pin on our Arduino Uno, and their negative is connected to one of the ground pins. And I've color coded each finger, representing the right hand, orange is the pinky, yellow is the ring finger, so on and so forth until we reach purple, which represents the thumb. And these, the wiper pins of these potentiometers are attached to the analogs of our Arduino. And this, like I said before, will be used to measure the positions of the fingers, and we will receive a signal between 1 and about 680, which we will convert that to value and we will then use that in our software to control our servos. So the servos are hooked up to the 5 volt pin on our Arduino, and again just sent back to the second ground pin. And we have for our signal the same color-coded finger color coding. Lastly, in order to provide a tactile response on the palm, we are using 4 vibrotactile motors, which will be activated when the player when the software detects that contact is made to the palm of the user. The vibrotactile motors will vibrate to give that feedback. So if we start our simulation, due to the fact that a lot of the electronics for the haptic glove will depend on the driver and the software being run, I have simply set this up so that in moving the potentiometers, it moves the corresponding servo. So as you can see, with the servo, we can set an exact position, and I will explain how we'll use this to our advantage once we go into the Fusion 360. So stopping the simulation, we'll go into Fusion 360 right now. So here we have the design for the casing for our haptic glove. So I've modeled a sort of mock hand based off of my hand's measurements, and sort of built the hardware around that. So as you can see, the vibrotactile motors are positioned at each corner of the hand. This was done so that we can have different kinds of grips, from say like a diagonal along the hand, or using all four to sort of get the full surface area. Due to the scope of this project, during the Fusion 360 prototyping, we dropped 2 of the motors. So now we are only keeping track of the thumb, the index finger, and the middle finger. We will be able to basically map the ring finger and the pinky's finger to the middle finger's current state, because realistically that's all we'll really need. This casing on the back placed on the arm is where our Arduino is, and we've downsized our breadboard from the half breadboard that we had in Tinkercad to this 5x5 mini breadboard, which should have enough channels and pins for our purposes. So you can see for this Arduino casing, we have outputs for our USB and our power, some ventilation holes to prevent overheating, and this forward hole will be where all of the wires come out of the system. You can see that at the tip of on the mock hand, we have these sort of caps on the fingers. These will connect to a wire, which will be connected to our spool assembly over here, so that when we bend our fingers, it pulls on the wire, which turns the spool, which is picked up by our potentiometers. And along the back of the index and the ring and the middle finger, we have sort of these guide nodes just in case. So let's look at an exploded view of our haptic glove. As you can see, we have the vibrotactile motors on the bottom. We have our guide nodes and our tip connectors over here, our wiring assemblies, the breadboard, and we have some further exploded views of our control case over here. So you can see we have the Arduino, we have the bottom portion of the casing, the top lid, all of the screws, and this hinge bar which goes through both hinge portions from the top and bottom and allows us to do our rotational motion. I have sort of double exploded this our wiring assembly because it requires, in effect, two directions. So we have our potentiometer at the end here, which is what we will be used to measure the length of the spool, and then we have our sort of main tensor component. We will use a tension spring that is coiled around the potentiometer and connected to it in order to have it so that when the user unclenches their fingers, the wire is automatically retracted. Here we have the spool where we will have our wire and the sort of outer casing, and this screw will connect to this hole here and will stick out ever so slightly if we go. If we look at some of these other wire assemblies, you can see that this screw sticks out. So as the spool turns, it'll turn clockwise, and it will hit this sort of paddle that we have on our servo, and that is what will provide force feedback. So by detecting essentially how far away the finger is from an object, we can, or where the object is in relationship to the hand, we can determine the maximum distance that the finger should be able to curl or close, and set the servo angle preemptively, or alternatively, the servo can push up against the this screw in order to push back the spool assembly. These have been the designs for the VR haptic glove. I hope you have a good day.